Hey, everybody. Hi. Thanks so much for having me. I was supposed to demo at the physical NWBA conference this spring, but that didn't work out either. So this is the next best thing. And thanks for tuning in. That the NWBA has been a fantastic group since I started the hot work in '95, and this is really great what they're able to try to do while we're in the situation we're in. So um, but if you hadn't noticed or looked at my profile and all that, I'm kind of a nuts and bolts guy. There's so many fantastic avenues of metalwork, but building and construction is something that's always interested me. And I found out after building bridges and things that my heroes were guys like Gustav Eiffel and Joseph Strauss, who designed and built the Golden Gate. These guys took metal and they said, people were like, it's never going to happen. You can't do that. And they went and did it. And now they achieved sort of immortality through steel in their own way. So if I can have a little piece of that, and contribute to maybe the public good, building bridges and these things, then that's great. So I like to, with that, take you towards our project here, which is something that in a lot of construction, unless you have a 3D scanner or laser in your pocket, you need to be able to quickly kind of characterize a job site, maybe for a railing, maybe for a set of stairs, could be anything. So for $26, you can go to Home Depot and get a tinfoil protractor that is basically like a tin can, very flexible and soft. So I finally took the time and decided to make my own, which is quite a bit more robust. So pretty much looks like a straight ahead tool. However, there are a couple things in it that will scratch an itch here. And that is number one, the rivets. But number two is this little dog leg offset. So, getting things to work, it's basically a mechanism. So if you've built hinges, gates, doors, and things that things have to slide and be somewhat parallel. So if we didn't have this little dog leg here, then there would be a gap, which would kind of negate the cleanliness of this thing. So yes, we've cheated. I do have a little plasma cutter that made this sort of half moon shape. That said, a simple blacksmith exercise, certainly if you have little remnants of pipes laying around, these are really good exercises for edge bending material. Speaking of rolling in that, Kellen, about how difficult we know taking this sheet of bar and basically bending it. But fortunately, because we're blacksmiths using heat, that becomes much more simple. So what I have made for something like that is these sort of pins can drop down into my table. And I put these things here and there and then heat up the middle of a bar and you can literally get a radius, or kind of cinch them along. Now that's if you don't have a plasma or oxyacetylene or whatnot. So basically that's our arc. And we're going to put a dog leg in this. So the simple task of offsetting and not much unlike these little curtain rod brackets I made yesterday for a client here in Seattle. They're very simple. However, simple bends. It's something the blacksmith can do better than anybody because these sort of tight little bends like this, you're not going to do that very easily cold. I mean, this was all done by hand, hot. So really helpful to have heat in that case. And similarly with this one, I'm going to toss this in the forge for a couple minutes, and we're going to press this in over here. This is, I call her Babe, the Blue Ox. I don't know how, but this press was only $400 when I bought it. It's literally made my life's income for the last 10 years. They're very useful. It is a 5 horsepower. I've got the, it's the 11 gallon per minute pump for the hydraulic nerds that motor speeds and all these are very attractive to a lot of people. It's not overly fast. I have faster pumps and presses in that. You'll see, however, it's kind of my general utility press. You don't want it so fast it's getting out of control, but it's nice when they're slower. They're often more powerful. So for this press, I like having more power up front. The others, I'm more interested in speed sometimes for the riveting. So what's nice about this press is that it's got this great big flat surface here. You know, like sometimes power hammers and presses use very small contact areas that can move a lot of metal. However, this big area is nice for getting a consistent sort of shape. So can you get a picture of that, Bart? I'll maybe try to get these offsets. Basically, we're going to be pressing this one down in that fashion. So we're going to get this sort of dog leg right here. Again, seems simple. And sometimes...
Question about your press.
Yeah.
The foot pedal control down there, is that running on like a push-pull cable or is it a bar? Or?
That's so funny, Kellen, that when I first installed this valve on this thing, I realized that with the hand lever, when I pushed it up, it went down, and when I pulled it down, it went up, and I'm like, what happened? So it's actually a friend of mine, and I haven't seen him in 10 years, but he suggested this foot pedal arrangement, which we built this little rocker pedal here. So this is the $100 Prince valve from Surplus Center. I really love that place for all the hydraulic fittings. I have, these are quick releases to power other tools in the shop. But yeah, the foot pedal makes it really handy. So look, Ma, no hands, right? And because that is critical, a lot of times we're wrestling with the material. So somewhat by accident, it turned out to be okay by foot power, because it felt weird, like everybody that tried the press would be automatically going the wrong way. And it's funny how when we walk up to a machine and you pull a lever, you expect something to happen. But my brother-in-law is an industrial designer, and he talks about that. It's actually a whole new field of industrial design, and they call it user interface, right? So you get into a car and you're like, why in the hell is this button here? What is it? What were they thinking, you know? So I'm putting in the whole rainbow here. See if I can get it in there well. Might be one at a time. I guess so. That's all right.
You might be able to build those bricks out a little bit and get some.
I'll figure it out.
So you said you had some quick releases hooked up to that valve. Are you using that same hydraulic power pack to run other equipment then? I
am, Kellen. I've actually got 2 other machines on it that they're running in series. So I have this, this is a 50-ton punch right here, and we're going to use it in a little bit. So That's one of the beauty of hydraulics is that, yes, it is a bit of a cluster on the, the plumbing disasters get bigger. However, it's very handy to, and I have enough hose on this punch where I can roll it out into the middle of the shop. And basically, if I get some big load of beams or angle iron in or something you need to chop up, which as a metal worker, yes, I do a lot of fabrication day to day. It's no secret, Seattle's a very expensive town, so you really got to hustle. I wish I were doing hot work every day and playing around, but the truth is you really got to scramble to pay the bills here sometimes, and that means just doing stuff for contractors or builders or guys come in with broken trailers. We have a sewer contractor next door that every week they bring in something they broke. So really classic blacksmith stuff of repair and that. Okay, well, we'll try one side at a time here. I'll see if I can get the other side. Really, in a lot of bending stuff, you don't need a yellow heat. We're just trying to soften the material enough to just let it conform. And that was a Grant Sarver thing that when punching holes in that, you don't want to get so hot that the material just rips and swells in that. If you leave some, a lower heat range, that it'll deform the material less. So it doesn't look like much, but I think we're okay. It's got just enough.
So you're just eyeballing placement on this. It's not.
Yeah, I'm gonna bump it up right here. So I just ran it up to the back, and yeah, this is, I'm just looking kind of at a sight line. I'm gonna give it a little more flattening there. I think we got it.
So Steve, if someone doesn't have an awesome press like this and is able to put both those joggles in at the same time, how would you go about doing this if you were new to the trade and you needed to stick some joggles into a bar like
that? You could theoretically do it in the vise, like right here, where when you make tongs, you see how that's kind of offset. Are you familiar with
yeah, you just
doing that where
keep the reins?
Yeah, you can almost force in a little angle there. So it's really subtle. But you see we've got an offset now. So the idea So if you do that technique over and over again, you can get really neat sort of weaves in that for like, not unlike in furniture, how you can weave fabrics and things.
Yeah, just infinitely harder than with fabric.
Yeah. I tell people that come in the shop that everything's hot, sharp, or dirty. So, people want to come in, they want to touch and feel and look around, but it's true. I mean, once or twice after coming down off of a ladder and I got the horn of the anvil, in the back or the butt, you know, you're like, wow. So nowadays when I walk behind me, you know, everything's trying to fall off the walls and that around here. So I'll let that cool down for just a minute. But yeah, I've literally got 3 or 4 of these things laying around. I keep one in the truck because if somebody says, can you come out and measure a railing, that at the least how you use this is just, you know, I slap it on a set of stairs or something and get a level and crank it down. It's kind of a set and forget method that people have said, you know, can you gradate them or and I've learned more in this sort of work that you know, I used to try to micro analyze railing work and that to the 10th of a degree, but sometimes nothing beats just that actual measurement on site. That way I can come back to the shop, I've got this angle set, and what I often do is create a little this is kind of the what's the other side of an angle, it's the complement, right? So when you build a railing, sometimes you've got an inner angle and maybe an outer one, and so it's kind of a transfer method of measuring, but this way you've got a hard number. Actually, I don't even know what degree this is, so it's just basically we've relied on this found angle. So sometimes I will care enough to try to figure some stupid angle out to the 10th of a degree, but really that's where the artist comes in. It's like, if it looks right, feels right, you captured the true thing going on, that you know, you stand back and it's like, looks good. So that was a great lesson Daryl Nelson taught me at a workshop we did 20 years ago, and we had made a bunch of parts for a little sculpture, and people were agonizing over how to put everything together before we collared or tack welded stuff, and I had had a few drinks, and I said, looks good. And Daryl said, exactly. So, and what is that? It means not to dwell on every little, you know, is it plumb, square, straight, level? It doesn't matter. Does it look good? Yes, thank you. So shoot it, you know, and that's where sometimes shooting from the hip is the best thing, because and I've found that blacksmithing has helped me immensely in that. Is you know, you don't wait around. When it's time to go, you just do it. And people would be like, well, how do you know? And it's just like, no, there's no ask, you do. And I'm really big in that, and people will tell you it's in that moment, in the immediacy, that you see clarity, and everybody else is like, what's he doing? So that's familiarity, and just also that's what I love about the work, and particularly about the riveting, I think, is when, even if you have a group of people doing it, when it's done right, there's not a word that's said, because everybody, you know, from across the room, you give the guy the look and he's like, okay, I'm on it. I think that is just fantastic. And it's a level of communication we've lost when we now have just instruments telling us what to see, think, hear, and do, is this physical connection to getting there. So I'm going to lay this out, and we'll get ready to put a couple rivets in here.
Cool. Well, so Charlie Montrose is asking a question that I think might be
Charlie.
a can of worms here. I guess I would start by saying, got any experience with spiral staircases?
You know, you'd think. I have never actually built a full spiral. I do have a model over here that I've sold individual treads to builders that have built spirals. So believe me, it's something I've wanted to do, and I'm insanely jealous of people that get these fantastic, you know, $100,000 or higher staircases. You know, I think I heard Mike Bondi in San Francisco, $1 million for a staircase, you know, and they do like 2 a year. I would love to, you know, for whatever reason, they're not beating down my door for that line of work. So it's the sort of thing where you almost need to do it for yourself, because I'm sure I can do it. However, if nobody's beating down your door to buy one, then if you're going to make it just to sit around, then economically, that's not always the best option. So I get it. When we're learning, you know, you want to do these things to prove you can. But at some point, you know, something like that is very involved where unless I have a buyer, what's the incentive? So, and I hate to make it about business because when that creeps into the fun, then it can be, you know, work and work can be a drag sometimes. So we want to have fun in that. And yep.
When a spiral case has got such a large footprint, I think it'd be a hard one just to build to see if it worked. Well, maybe a miniature one's in your future. You can make a little mouse-sized spiral staircase and just get that. You know.
No, I agree. Like that model, that thing. I want to finish with a nice forged handrail and that, and that's something. Lisa Geertsen, when she taught at Pratt, had an artist out, John Medvedev, that he had a good saying, and that scale's a gimmick. So this guy has done monumental art. Look up John Medvedev; it's amazing. And but it's true. You know, if we can make something in miniature, then it's not too big a deal to scale it up, right? So, and that's something that the rivets really helped me realize was that one of them's not a big deal, but suddenly I was able to capitalize on that knowledge and of being a metal worker, and suddenly I'm getting phone calls from around the world like, hey, can you come look at our bridge? And we don't, that's what's maddening is we forgot more than we remembered about how these things were built. And they these riveting techniques were with blacksmiths, you know, and iron workers that are just like us, you know, blue collar. They didn't typically gloat nor share a lot of their secrets. So it was just common knowledge how they did their work. So, and that is that, you know, one rivet is not a big deal, but 6 million of them get you a bridge or something that, and that was important for my evolution of scale and made me realize, yeah, I don't want to be just stuck doing stuff for homeowners and that. I love working for state DOTs and engineering societies. There's, you know, bridges and infrastructure all over the country that people are like, they'd be banging down your door because all these things are falling down, right? But in our society, everything's kind of disposable. So it won't be till there's another collapse maybe that they'll come and say, hey, can you come work with us on this? We don't know what happened. So, okay, I'm just kind of laying this out for a couple rivets here. And I'll have to punch some holes.
So for everyone to know, Steve has donated this piece that he's making, and so we will have it up for auction in just a moment. And I hadn't realized before, this thing's pretty large, so I think shipping might be a slight bit of an issue. So I'm hoping that one, it brings in enough money that we're able to cover shipping and that it's not just, you know, we're just paying for shipping. And so on that note, I would also say, I think we've got a few folks in the audience who are from overseas, and I think this one might have to stay in the US. This is But on that note, I'd say let's start the little auction here. Everybody wanting to take this home with them.
I think I've shipped it domestically in the US for about 40 or 50 bucks.
Well, if somebody from the Northwest picks it up, maybe we can just sit on it for a minute and do a handoff at some point.
Sure.
So Joe Elliott makes a comment that that scale really matters when it has to fit, and I think that's awful true.
I have another great saying, and that is was given to me by a trumpet player friend, and that is, they only remember you when you screw up. So you do your part perfectly, and nobody cares, right? But if you hit a bad note, then everybody points at that guy, right? So, or another Joe Elliotism is dare to suck, right, Joe? Oh boy.
Well,
Yeah, I
we've got a lot of good sayings.
you know, I do embrace Joe's dare to suck, because I'm not one of these sort of guys that everything just comes, you know, people come in here with Mosaic Damascus and I'm like, how long have you been forging? They're like 6 months. I'm like, 6 months, you know. It's just, you know, the internet generation now, there's so much data that comes in, and if you sit there on YouTube, you can get it all, and then that is remarkable, and you go to do it and boom, there it is. So I didn't learn like that. I had to kind of go out and struggle, and I'm old enough now where it was just old crappy DVDs and books largely is how I was getting into the techniques and that. But I do fail a lot, and that sometimes that rejection's hard. You know, a lot of tools and things I've made to make hammers and tongs, I had days or weeks into them, and one bad, you know, movement on the press, and something failed, and now it's all a welded mess. And I've gotten easier about just standing at the abyss of the scrapyard and and just, you know, something you put your life into, and it just get rid of it, you know. So
well, you gotta know to let
go. You know, we're trying not to make scrap metal, obviously, but
well, I think
and that's something that Joe, aren't you back in Mexico, or they won't let you back down there yet, will they?
No, Joe's not in Mexico. He's still in Bend, Oregon here. But Joe is asking, well, first he's saying, thank you for remembering all the wonderful things you said. But he's asking why you don't have a stripper on that punch.
There is, but the work I'm putting under it is too small to grab effectively. So so I just do the yank and grab, which is not too professional, you know. So basically, I'm just kind of slowly creeping up on this. And the big thing with any time, and again, doorways, drawers, closing mechanisms, suddenly, even tongs, think about them. Things have to suddenly work together. So I'll have to be very careful in making sure that my radius point is obviously, you know, centered between these two, and then we can start putting it together. Let me get a couple of 3/8 bolts. I'll be right back. Who else we got online? There's
Let's see some names you might know. Ann Bujol just dropped in a little while ago.
Oh wow.
Bhakti Saw is in here. Glenn Gilmore is currently high bidder on your tool here with a very generous.
Oh geez, Glenn.
$1 donation.
Glenn makes an amazing press. If anybody's looking for a hydraulic press, I would buy one of Glenn's, definitely.
Well, I'm hoping someday we can get get a little shop tour from Glenn and check out his equipment.
Did Glenn sell his 3B yet?
I don't know. Glenn, have you sold that 3B yet? While he's other folks, I think you might know Jeff Wilson in the crowd, Jim Garrett.
Hi, Jeff. Oh, wow.
Carl.
Hi, guys. That's great.
Rochelle's in the crowd. Joe's asking if that acorn table you got, is that a 6-footer?
It's 5x5, and the acorn was my first real tool. And in 1998, I moved in with David Lish and Pat Mayer and Matt Tilton and the whole Seattle crew into Ballard. And I think it was the first day I met Pat, and he said, hey, we're all going to get some tables. Do you want to go in with us? And I said, yeah, how much? And he said, $300.
Oh, that's
and even in the late 90s, that was an unbelievable price. So I said, are you kidding? Of course. So, you know, a platen like this is definitely about 3,000, 4,000 pounds. And it was the first machine or first tool where I'm like, oh boy, you know, I'm married to it now. So once you get a platen table, because before I was kind of building furniture on a concrete floor and then wondering why it went ding, 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 ding. So when you're able to have a flat surface like that, it's just been invaluable for, again, construction in general sort of thing. So I was just marking out kind of the center fulcrum there.
Well, Joe's
really simple.
He remembers that shop and that you've come a long way since then. And Glenn has not sold his 3B, says he's getting cold feet about it. But his two new words are reality and mortality. So
I saw that, Glenn, and I completely get it, man. I've lost a couple friends in the last few years, and it's been devastating to see all their hard work and that just got basically hauled out in a scrap dumpster, and it really made me feel my own kind of mortality. But I've been able to pick myself up a little bit since then and try to and move on. And that, yeah, ultimately everything we do, it may or may not matter, but we got to at least try, right? And not only that, but even though I've been on the West Coast 30 years, I'm a New Yorker. I grew up in upstate New York, ironically in the same town where Albert Pele was having his biggest, arguably, breakthroughs of any blacksmith at the Smithsonian and the Virginia and Albert, et cetera. And I was 15 years old and like, Albert, who gives a damn? I mean, I couldn't stand the place. It was dark and depressed Rust Belt town in upstate New York, and all I wanted to do was get out. But not to belittle Albert at all, but you know, we all got to find it in our own time. And David Tuthill got a great quote about we all got our own relationship with the metal, and there's so many flavors. You know, where do you want to go? But I think there's something to be learned from everybody that's got that's dabbled even a bit. You know, I'll try to have an open mind and be able to pick up some little tidbit of information. Where's the stripper, he says. So, yeah.
Well, one of the things that has always attracted me to blacksmithing work is that there's no ceiling to it. You know, I mean, you can spend your whole life becoming an expert in one aspect, and there's always another aspect that you can always learn more. There's always something else to discover.
I really like your the Herald series you've been doing, Kellen. That personally, it looks like you got too much time on your hands.
Oh, I don't have nearly enough. Not nearly enough time. Harold, I haven't seen him in a long time. He's in Russia right now, so.
Oh, wow. Yeah. No, I get it, man, that, you know, I would play in the fire every day, and I do lose money frequently when I forge, because there's not really an end use maybe, or a client waiting for it, but that sense of discovery, and that is, it's just such a part of it. And you know, like a child, that sense of wonder and awe, that because why, because you know, as we get older and we're jaded and grumpy old men, it can be easy to lose sight of that. Something that has been told to me, that I had enthusiasm, and isn't that such a huge component of this? Because you will burn your hands, you will crush your fingers, unfortunately, all that, and but that perseverance, it's why we're men and women of steel. And I think this is the most noble craft of all, in my opinion. And I just can't say enough about when people start talking about mythology and all that. I'm like, well, let me tell you some stories, and incredible sort of alchemy, and it's still happening.
Well, while we're on the topic of you know, good quotes from folks, Joe Elliott just threw out a granted, which is, if you're not making money, you're learning, and the trick is to not learn one time.
Yeah, or another one I use of Grant's frequently is, if you want to make a small fortune, start with a big one, right?
Yeah.
So, and but really, I have Grant to thank somewhat for my riveting stuff, in that I showed Grant and this is they call that a pan head rivet, cone head. So I showed Grant one of something like that, you know, it's just a rivet head. And he said, well, you made it on one side, what about the other? And up till then, the thought had never crossed my mind, where, you know, for fake furniture and all signs, you know, that's all that you do. You plug weld it on and you're done. But when you put the same thing on the back side of that, it becomes something else. And that's really when the door opened up for me. And then you take riveting from the realm of kind of the hobbyist to suddenly now you're building infrastructure and getting calls from Australia saying, come work on our bridge, and you jump. So oops, I got a 5/16, I needed to put a 3/8 in that hole. But maybe we're close enough, we can check this with a real rivet.
Steve, when you're putting,
speaking of,
if you're running a 3/8 rivet, are you putting a true 3/8 hole in there, or are you oversizing that?
You know, when we do these hot, which I'd like to, I might open these up a little bit. So what I'm wanting to check here is basically just make sure I got my pivot somewhat close. Oop, wrong way. Looks a little tight. What you want to make sure and is that it doesn't bind up too much in the slot. So when we rivet that, of course, really easy for rivets to get too tight, and we have to be really careful not to overdrive it. And I'll show you an example. And you can do this by hand too if you're not careful. But when you, and this was all done under a hydraulic press, and you can see this sort of serrated effect, which you may or may not find aesthetically pleasing. However, if these rivets were all along just this back side, this whole bar then becomes a banana. So you can see how much it's distorted the material. Not unlike if you did it hot, it's trying to displace that material somewhere. So what I don't want to happen on this tool is to have it so, so much pressure right here that it's going to blow this out. So we have to be careful. And on my blue press, I'll just basically feather it as best I can. If I were going to make a whole run of these, I'll take the time and adjust the pressure on the valve to be a lower level, because that's the surprising thing is many times when I'm building bridges or driving big rivets, we're trying to get as much as I can out of everything I've got here. So it's my biggest horsepower pump is 15. I'm gonna go to a 30 horsepower pump eventually, because the old saying, there's no substitute like cubic inches for horsepower, and that is in hydraulics. It's something that with the riveting I've noticed and have read a lot in old accounts is that many believed, a blow was a better way to deliver that force than a slow squeeze. So to get a blow with hydraulics is, basically you're trying to huff through a fire hose basically to get that volume. But I would classify kind of the structural rivets. They start at about 1/2 inch. If you're at 3/8 in that, and really these were some of the first things I ever riveted together were some of my own tongs, and I do sell a lot of these things to I call them potter's tongs, or raku. Put raku in the middle, raku tong. Suddenly it's an $80 tong versus a $40 tong, because what blacksmith wants to pay $80 for a pair of tongs?
Well, it depends on who made those tongs.
I hear you. So I think we're close. I'm gonna set the press up for the rivets. And I'm sorry, Kellen, do you have something to say?
Well, we have a question from Charlie Montrose. He's wondering if in certain applications, like maybe this one, to have a countersunk on the back side of that so that the rivet head is out on both sides. Is that something that you do?
That's a great, countersinking any sort of fastener. It helps kind of create a bearing surface. So I may do that now that we kind of got that fitted up. Yeah, just relieving the holes. So what that also does, as Charlie may suspect, is that it just creates a better sort of bearing, that it's not a sharp drill cut edge or something. So and if you look at a lot of rivets, and I'm going to grab that cheap tool, that if you want an industrial grade protractor and go to Home Depot, this is what you're going to get. And, these are tubular rivets. So they kind of solve that compression problem by just doing these little dink. But yeah, you're never going to hold together, much structure with the hollow rivet. So, kind of like bolts and welds, there's so many different flavors. And I don't know if people had seen my story on Instagram the last couple of weeks, but people are like, oh, they don't rivet on trucks and things anymore. And my neighbor's got a fleet vehicle dealer, and there's a 2019 brand new flatbed. Guess what? The whole darn suspension has rivets. And then some guy on Instagram's like, those aren't rivets, and so it's funny to see how much almost disbelief. And that was one thing that really drove me about it, was when I first started poking around in the rivets, everybody's like, don't work, too old, haven't you heard? And these were like engineers. I was hanging out in these chat rooms of engineering tips, and these guys all think, they know everything. And I'm like, well, they work. And that was particularly true after these producers called me up in 2011 and said, hey, you know, the Titanic story, Rivets failed, ship sank. I said, yeah, everybody knows that. That's what we've been taught, right? But these guys had some really preeminent sort of luminaries and PhDs that really described that it wasn't so much a problem with materials in the ship. You know, obviously it hit an iceberg and sank. But to say the rivets were the only thing that was bad, and that's the reason for the whole failure. And this is where I get really angry about it, because you've now slighted the thousands of people that made that iron, that smelted it, that made the rivets. It's like people around here with an 8th grade education, if they get the job at Boeing, it's the best thing they ever had. So similarly, at the turn of the last century in Northern Ireland, where they built that ship, I mean, those were the best jobs in town. You didn't screw up. And that's something Dave Thompson, a Eugene, Oregon blacksmith, said. He's like, you know, these engineers and that, they don't understand it because it's craft. And craft is something that Grant said, to keep bouncing around between quotes and idiisms, is, you know, craft is what, it's something that you can't easily put a finger on. However, the biggest component of it is pride. And if we don't have pride in our work, then yeah, you get a crappy product. But to say the rivets were bad, that people didn't care, BS. You know, I think the materials in that ship, there were 2 or 3 other ships that were built at the same time. They sailed until the 30s or were sunk in the First World War. So I really feel strongly about that, that yes, a lot of bad things happen. Were the materials somewhat substandard? Sure. But you get the same thing that happens now. So so when people say rivets don't work, bullshit. Oh, pardon my French, but
don't worry, I think we can edit that French.
Okay, so I'm setting up for my little rivet job here, and you can, you know, you don't have to have a hydraulic press to do this work. Me, you know, trying to mimic the bridges and things that I'd seen, that I was really inspired by, it really led me towards using the hydraulics, where it just allows me to be more consistent and repeatable, and to do it as basically a one-man army, which is what the shop is. And I love when people look me up and they're like, hey, you guys, can you guys do this? And I'm like, no, it ain't us, man. It's me. You know? So that we want to make it look like there's an army of us here, but in fact, it's just it's a small one-man operation, right? So let's see here.
So Charlie Montrose brought up some pretty good points. I think that you know, the rivets give the structure more flexibility compared to a welded structure, and that the welds, since they can't flex, are more likely to fail, and that people at the time of the Titanic didn't understand the steel, and it wasn't until the second and the failure.
Yep, I agree completely that having been a certified welding inspector, we were taught welds were going to save the world. The welds are stronger than the base metal, Well, it turns out that's the problem, is that, I mean, we don't like getting out of the shower, jumping into an ice cold lake, but that's just effectively what's happening when you go weld on a piece of metal. I mean, you know, in hindsight now, they found out it's not necessarily the weld, it's the area between the weld and the base metal that gets, they call it sensitized, where the thermal properties in that, you've created stress, and that's something else that drives me crazy in a lot of engineering books, and that they don't account for all the welding distortion in that. When you look at how badly things can get into shaping in that with welds, and none of that stress is accounted for. But when you look at cases of cracking and corrosion and that, you need like 3 things. You need stress and you need a sensitization and that, and you're already halfway there when you have welds like that. So.
Well, I think we might have titled this demonstration wrong. We should have called it Steve Howell Gets Heated About Rivets, Welds, and the Titanic.
Right. Yeah.
It's suggesting that you might need a Snickers.
Well, no, it dawned on me when I really started to get a voice about that, the rivet stuff, was when I felt like I had to defend it when people are like, well, we don't do that anymore. And I'm like, well, I do. What's wrong? And they're like, poo poo. And I got to find another rivet die here. I'm sorry. I had the wrong one. So.
Take your time.
But, isn't that when we decide to take action sometimes is when, and it's something my sister said. She's like, well, if enough people keep saying no, 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 then maybe you're on to something. And that was kind of an eye-opening moment when it dawned on me that maybe she's right. And that just because people aren't doing it so much anymore, I gotta set this up. So I run it loose.
Oh, no, go ahead.
I'm listening. So
you see your
pretty easy to see how I'm kind of lining that up, and then I'll tighten it up. But yeah, if enough people say, let me say this, is that if you're blacksmithing already, that you're kind of off the normal sense of economy that most people use, right? And that what we do isn't necessarily in our techie society where people place more value on punching a keyboard than, say, keeping the bridge standing, then that's another sort of labor questions. Like, why is that more valuable than what I support? So, but I don't try to get too philosophical about it when people are saying, oh, nobody does rivets anymore or this and that. One of the reasons why I was sticking with it was because nobody else was doing it, and I'd ask around and everybody just shrugged their shoulders. So, and I know that, I'm not a good knife maker or things may or may not interest you. So, and that is when we're starting out. Yeah, I did a lot of classic, I do love Gothic ironwork, and the Italians were some of my favorites, and all these sort of quarter foils and these things that I'm going to show Bart here in a minute. I love classical design and would love to incorporate that sort of stuff. This is a trace cool. I took out of, you have Das Eisenwerk, Otto Hover. It's one of the best old German sort of ironwork books, but I literally traced that out of a book from, I think it was out of Florence. And my first iteration was going to be to put it in a frame, but then somebody is like, well, that's stupid. Why would you want to fix that in a frame and lose all that? So, so I do love classical design. And, but unfortunately in Seattle, there's just not enough people that really like that kind of work. I might get a call for traditional work maybe once every 2 years. If somebody got a wine gate or cellar or something that international style modernism is just about it is the design aesthetic around here. And I've got a saying that metal workers these days in Seattle are not. They're interior decorators. These guys suit up in patina smocks and they're doing chemicals and etches all day long. you know, that's interior decorator stuff that I hate that it's kind of gone to that, but this black and steel that seems to be the rage and modern architecture, to me, that's just like changing the blinds. You know, I want to be the guy building the house instead of the guy just finishing the curtains on it. So with that, I think.
Well, before you set these rivets, I just want to give a shout out to everybody in the audience to thank you for continuing to join. It looks like Gin Glomar is still high bid on this angle finder with $250 if anybody wants it more.
Wow, Glenn. Jeez, that's great, Glenn. Thank you.
Yeah, and I would also just, you know, remind everybody that it's through generous donations like these that we can continue to do all this programming. And it's real easy to hop over to our website, blacksmith.org, and we have a donate button. And if you think this is worth your time and worth your money, any donation is very helpful, whether it's, you know, $5 or $250. It helps all these things keep moving along.
Absolutely. And I'm really thankful for you guys for keeping after me for doing this. That the NWBA, you know, when I first started going to them in the mid 90s, I didn't know anybody. So I'd literally, and I'm sure a lot of, you know, young members can relate that I'd literally go hide in the corner and you watch attentively and it's exciting, but I was almost embarrassed. You know, I couldn't, people would say, hey, you want to step up to the anvil? I'd be like, oh, no, I don't, you know. Feel like we didn't know what we were doing or something. And but since then I've gotten some great friends, and that open forge, and that is it's just something that is just, it's a really great thing. And I know what is it, it's coming up on 40 years, or it was 40 years in 2019, is that right?
41st.
30. Yeah, right. So I'm going to ream these holes just a little bit. And, you know, that's the funny thing. Right now, the rivets are tight, you know, they kind of go through, but guess what? When they're hot, suddenly it's kind of maddening, and then they won't fit. So I'm going to go just a little bit oversized. And it's really important to, and this is a pretty simple mechanism, but if I'm riveting together a staircase or something or other, that pre-bolting everything, you know, it's just, you don't, you can always loosen bolts and move things around, but not unlike welding, once you kind of go setting it in stone, that it can be hard to deal with. So, and I don't know how many of you have tried to drill rivets out in that, but it'll give you a real insight to how they work. And the more poorly aligned the pieces of metal are, they work better, because as that rivet swells up, they kind of work in there, and that prevents you from just driving it straight out. So let me get my drill ready here. I'm sorry, just take a second. Go a little oversized. We'll do a 30-second.
Well, I think we're all looking forward to the day that we can get back together, because I think that, you know, seeing each other in person at these conferences and hammer-ins and things are really the best way to learn. It's great to be able to visit the internet and watch videos, but nothing like hands-on learning.
No, I agree. And yeah, just that camaraderie, and made some great friends, definitely. And you know, I will say that's what had prevented me from the last couple of years, was every time it always seemed like right around May, when the conferences would be coming up, I would get a job saying, hey, we've got a project and such, are you interested? And once again, you kind of drop everything to go I'm going to get this a little more rigid here. Want to see me break a drill bit?
We all know that feeling.
Yep. So now we should get a little more clear shot there.
Brian was asking if you could talk a little bit about hot versus cold setting. Like, could you do a rivet this size in your press cold? And would you?
Yeah, but you run the risk of it's kind of very touchy. I mean, you want to upset that thing until you get that head just such, right? But if you go beyond it, that's when you start to crush the base material. So it's a very delicate setting where you almost need to either have a kiss block, which a kiss block is something that physically stops the press from going further, or you could do a limit switch, you know, electro sort of switch, or you have to do it with the pressure. So what I do frequently would be to back off on the pressure that the pump is delivering, because yeah, if I drive this full strength on that tool, it will just destroy this joint. So the trick is to try to just get it closed up enough and not go too far. So I have found evidence of 100-year-old manuals that said if you can do them cold, do it. And it's kind of the Grant thing, you know. If you're heating the material, you're wasting money or whatever. Or if they can do it cold, they would, sort of thing. So and you know, I just like hot because it gives a better, you know, if you look at how these are made, they get a nice sharp edge on them. These are 100-year-old rivets. The ones you buy nowadays, they're not as well made. They upset them cold. So that's something I'm always looking for, is just a nice crisp edge, and you only get that through a really rapid forming of the material, and it's even more pronounced the bigger rivet you get. Obviously with circles, you know, you double the size from 1/2 to 1 inch, you quadruple the area. So the power needed to make that same head, it really it goes through the roof. So the old rule of thumb about 1.5 times the rivet diameter, give or take. I tend to go a little bit beyond that because I've made a lot of my own shapes that, while they seem to fit existing rivets, that's kind of the gauge I use to check the fit. It's not always the case. I found historical examples and even literature that said plus minus 10%, no problem. So that's why when you look at an old bridge or something, you see maybe a variety. And I've gotten to the point where I can read those things like Braille. I look at a bridge and I can see where they had a shift change or where the new guy came in, or there's 2 rivets here that look like an abortion. So what happened there? But they all tell the story of labor, you know, and how those things were built. So I'm gonna mark this one here, and I might as well show you this tool I got, and we'll use it.
Steve, the bolsters for the rivets that you're using, what kind of material are you making those out of?
I've used just about everything, Kellen. These I made for a little air hammer from S7, which is a great material. You know, anything mild steel I've used. However, you know, that heat that gets absorbed in a rivet, in the die, working the rivet is really intense. So if you're going to use kind of cheaper steels, you have to either cool the material more frequently or, you know, just do less of them. So I have some dies I can show you guys. Hope I can get enough swing on this side. We did, I think about 2,500 half-inch rivets in this on the Army Corps of Engineers job, and the PhDs came in, and I said, well, maybe you guys can help me calculate how much stress it takes to cut a half-inch rivet. And I think they said it was about, on the end of a 6-foot handle, it was like 20,000 pounds of shear here. But I told the guy, go ahead and pull on the handle. So he did, and he didn't break the rivet, and it threw him on his back. He landed on his rear on the floor, and it was a little embarrassing for him. But that was a good sort of show to show you how much. It's 1 1/8, of course. To show how much power it takes to shear a rivet. And most rivets you buy are what they call a grade 1. And grade 1 is 1018, or it's a very low carbon.
I'm gonna see. The shear that you're about to use, is this a tool steel or mild steel? What's it made of?
This thing is a piece of leaf spring that I annealed. So I heated this up and let it cool off overnight in the forge. And then it's basically 2 pairs of matched, it's the same material. I cut about a 6-inch piece off and then clamped it together and drilled some pretty clean sized holes. And then hardened it. So it's basically like some 5160, and it's got an oil quench, and occasionally, even on this stuff, I'll do a case hardening, which in a high carbon steel doesn't maybe do that much for you. Try to creep up on this length, I think. So 3/8 are no problem. But again, this is
as long as you're
6-foot handle. So that beats cutting them with a bandsaw, you know. And if you want to do 200 of them like that, that'll get you more. Just check the length of that. I think I got to space that out a little bit. So we'll go ahead and, but yeah, I've done up to 1/2 inch on this, and you really got to kind of snatch and jerk that handle. If you just try to creep into it, it's going to put you on your back. So.
Well, I got to think if you have enough of those to do, you get your blacksmith CrossFit in for the day. No need to go to the gym.
Isn't that funny how, yeah, I tell people that you don't need a gym. You just come in here for an afternoon, you know. I'm going to space it out here a little bit, and then. So I just kind of creep up. Really, you know, what I like to do ideally is get a test coupon where, you know, when you make a weld, you make a coupon, right? But that is to basically try out the joint. So I would make a bar with a bunch of holes in it that then I would cut a couple different length rivets, and just go ahead and run them and see which one you like. And it's such that 1/16 of an inch or less over or under seems to make a big difference aesthetically and also sometimes structurally too. If there's not enough material, like if you try to press that rivet there, what happens? It never creates enough mass to kind of gather and upset into much of a clamp, you know. So, and it's kind of like that thing about Grant saying, you know, you put all that force into one side, but that's what people don't realize is that the Newtonian whatever force goes into the front, you either got to resist or meet it in the back. So that's why bucking and the resisting is so important. And we lose sight of that when everything is usually just some sort of front looking movement. So I'm going to go ahead and that's probably, what have I got? You know, I'm going from the hip here. So it's a little greater than, so I got, you know what it is? It's almost 1.5. So I got, it is. We got 1/2 inch of grip, they call it, the total thickness. And I got a 3/4 inch stick out. So it's 1.5 times the thickness is your stick out, they call it. So should get us close. And again, I would rather have more than less, right? I don't want to get that rivet so hot that it'll get so scaly that you can't get it in the hole. And then that's frustrating. You've got everything ready to go and you're like, you know, and the classic strike while the iron's hot. Great quote about all that from Don Streeter, classical kind of Williamsburg colonial American blacksmith, said, woe be to the workman that comes to the anvil without, you know, a clear image in his head where he's going. So in other words, and we've all seen it, you know, a student, somebody, you come out of the fire with a hot poker and you're like, what do I do? You know, you didn't have a clear idea of the immediacy of where you're going in that. So I think that's something about the rivets that I really found appealing, is like there's all this waiting around, preparation, and then go. It's like right now, it's over. And like, what happened? You weren't paying attention, you know, it's over. So, but the beauty in that is that, okay, well, that one didn't go so well. We got 2,000 more to go. So then you start getting into this Henry Ford mass production sense. And we're about ready to roll here. So again, not too hot. Just a little 3/8 rivet. I'll hold it right up here. I'm going to go nice and easy. Beautiful.
Just like that.
If you go too hard, you're going to see where the mill scale will look like it exploded, and that will tell me like, no, man, you hit it too hard. So if you see the material getting thin, so that was all strictly foot pressure. I could have kept going, but you know, that's one nice thing about a power hammer or something. You get a little more input and kind of push and pull and feel it. The hydraulics don't necessarily have that. You know, they're usually all or nothing. So really easy to overshoot it. That's a really permanent joint now. So what I love about the technique is when you get done, and you've seen these fire pits and things I've made, that a riveted structure rings like a bell. It's just like gung. It's just like, whoa. Like you don't get that sense from other methods of construction. And why is that? And I do believe there is a kind of musical analogy in that, and that is, you know, like a bell, it's a continuous piece, right? that you get a kind of a solid item. And the more I've dealt with that stuff, it's like, wow, you know, yeah, I should let Bart try a 1/2-inch rivet and see if he can get it in one shot, you know. Yeah, 3/8 is nothing, but again, yeah, from 3/8 to 1/2 inch, you're the pressure on, I mean, you really got to get on that thing, and it's fun. So kind of becomes a bit of a challenge. About 20 years ago, I went to there was an ornamental iron shop that was closing up downtown, and everybody was all gaga over the tooling and the drill presses and all that. But I said, oh, what's down here? There was a little crawl space, and I discovered a bunch of kegs of rivets in dirt and dust that was about 6 inches deep. And I still have these wooden casks of 100-year-old rivets that everybody else had looked completely past. But I love that about our medium is often our material isn't usually that expensive, is it? You know, if you're good, you can kind of recycle a lot of what you need out of an old automobile or something. You know, leaf springs right here were scrap. And isn't that easier than, you know, doing it with the bandsaw and all that? I mean, have you ever tried to cut this stuff on a saw? You're going to hurt yourself very easily. So I have to, that's it for that. So yeah, rivet shear, I've got 3/8, quarter, and 1/2 inch. I thought about trying to put another hole in here for 5/8 of an inch, but I'm afraid I'd throw my back out or something. So I do firmly believe in leverage and people power. However, there becomes a diminishing point of returns after a while about what can we expect to get out of it. So I got that hole.
Steve,
You know what? I mean,
ask a clarification question. So Brian Campbell's asking that, you know, when you're measuring for the length of these rivets, it's based off the diameter of the rivet is that 1.5 times kind of plus or minus, right? It's not.
You can use that. Well, if we did that, then I'd be at about 2 times the thickness, because our diameter's 3/8, but my stick out is 3/4, so that's 2D, right? But yeah, so I know that's the classic rule of the rivet diameter. You're right, but in this case, if I were only out at 1/2 or 5/8, we're not going to be able to fill that cavity. So
it's kind of a mix between rivet diameter and the length of what you're going through to kind of get
between theory and practice, yes. And that no, you're absolutely right that the classic formula is related to the rivet diameter, but some of that is not every rivet head conforms to a historical sort of size. And, you know, really that's only because I like symmetry and I want these things. That was always the look I was trying to achieve in classic rivet work. Was we all see the classic, you know, hand hammered, 4-sided pyramid. That's great. You know, I always wanted to be consistent, and maybe it meant acting more like a machine, but I would say, you know, give yourself enough chances and make up a test bar like that where, you know, you can actually see here, look at this one, looks a little small. Like, and maybe I started, speaking of kind of reading the Braille record here, this was probably the first one I did. And if you look closely too, you can see the die contacted the base material. You see that? That's because there wasn't enough material to fill the cavity. So I probably saw that and said, no, I need to add a little bit. So I like kind of fine tuning the lengths, and it's just an aesthetic. And if you're just making tongs or something that, you know, get it in the hole and get it done, it's not a big deal. But I was just trying to mimic the guys that whose work, and that's the irony, man. Riveted construction holds up just about every major bridge in Seattle. And it's funny, one of the newest ones is 35 years old. It's a concrete bridge in West Seattle, and guess what? It's closed because it's already failing. So, I mean, we've got 100-year-old bridges that are still doing. Are they still doing their job? Yeah. You know, are they less than ideal? Well, maybe, you know, but that's classically what's happened is, you know, loading gets heavier and heavier. They get bigger trucks over time. Bridge designs from 100 years ago may not be safe anymore, but guess what? They still seem to be standing when the newer ones are not. So that's another thing where I go back, and similar to my progression through the craft is when I started, I had to have all the latest and greatest air hammers and techniques and all that. And now I go back more to, I've got a mechanical power hammer, which if we have time, I'd love to do some work on that. And go back to just older methods, and they're fine. There's nothing wrong with them. Number two. So that really is a lot of material when I'm at 2 times the diameter. But for me, the quality of a good driven rivet is if you can't tell what side's coming or going. I can't say enough about that. And you'll see plenty of examples of sloppy rivets. You know, it's funny how many people ooh and ah over a pretty weld on social media, but you know, so you can weld. So what? You know, what are you going to build with it? So that's kind of how I feel about rivets. Is that yeah, it's unique and all that, but ultimately, hear that? Sounds pretty solid.
Yeah, it sure does.
Right, got that ring to it. So we're getting there. Kind of get the money shot here on this one. That one we can almost just do loosely. And I'm kind of impressed with myself that normally when I do this, and this is something, it's got a tiny bit of a bow. That one distorted right here. It's got a tiny bit, but I can, you know, and that is from all this pressure. So, but granted, you know, if you'd done that with a weld, it would have pulled too. So after I put this all together, I'll kind of put it on a flat, straight edge, and I'll take a file to these things and kind of square them up. But, you know, and you could have easily put this whole thing together with welds, but then it wouldn't be so cool, would it?
Nope, sure wouldn't.
No, just... So how did the knife makers thing go? You said, Kellen, that
well, they've done 2 so far, and the last one, I mean, so much great information. We just had a little bit of an internet problem.
Sure.
And so we're hoping that we can get Rochelle
Right.
back and do it again, where it's a little clearer. It's kind of
it's just
the unknown challenge of all these is how the internet's going to behave. Everything looks beautiful. We can hear and see, and everything's great. And out of nowhere, everything crashes.
Right. I know the first time Bart got a hold of me and we tried this, that my phone was all dead and we couldn't connect. So I'm really happy now that we've got a good connection and get over my internet phobia so I can do this again in the future. You know, and a lot of my videos in that I have done on social media. I haven't sat there and narrated them. And, you know, I think a lot of people like being spoon-fed now that, well, today, you know, this is what we're gonna do, and and all fancy editing and that. But I've always preferred to let the work speak for itself. And I get comments like, "What are you doing? Can you tell us?" You know, it's just like, hello, you know, the work is it's right in front of you. So it doesn't you know, people have to literally be spoon-fed sometimes, and that I want there to be a little mystique, you know, like I'm not going to give away the keys to the farm in one shot. Like, you know, I want you to try to, if people say, hey, you know, I watched what you were doing and this looks cool, can you tell me a little bit more about this or that? And I'll be glad to answer those questions. That
Well, it's one of the things that I really like about these digital demos. We're not really trying to make a high quality YouTube video necessarily. It's a little more informal, a little easier just to kind of, you know, talk our way through these projects without trying to produce some, you know, set in stone forever and ever quality. At least for one, could definitely
do these
do this again with you.
yeah,
It's been a whole lot of fun just chatting with you as this is going as well.
I mean, these don't get archived or anything, do they, or do they?
Do they're all recorded, and we're kind of just doing a real minor editing to it. You know, if you drop any French words, we might edit those out, but then they just kind of get put on as is. So if somebody missed this live, watch it again. But live's really the way to watch them, so we can ask the questions.
Oh, that's great. Job opening. We need a new video guy.
Well, he's been doing great up until then.
You're fired, Bart. No, I wasn't sure how I was going to deal with all the camera stuff if Bart were not here, so that's very helpful. Yeah, I just basically got this one fulcrum one to do here. Looks like I'm going to need to file on that end a little more.
So this fulcrum one, are you not going to set the rivet quite as deep as the other ones because you want it to move a little bit?
No, I'm going to hit it pretty hard, but what we're going to have to do is kind of loosen it up. So just like a pair of tongs, it's going to be really stiff in the beginning, and we'll work into it. So it may take a little wax or something. Not too bad. Sometimes I can't even move it without jumping up and down. I have made riveted test coupons in that when people are like, oh, it's not strong or something. And if you do that with a 3/4 inch rivet and set that thing like it's supposed to be, you will have to be beating on that with the sledge to even get what's basically a hinge to move. And it's just astounding how much, not only does the hydraulic press exhibit that clamping, but also after the rivet cools now, there's basically a tensile element to a rivet, which that was something else Grant taught me, was that for every inch of material at a red heat from 1500 degrees to room temperature, it changes 10 thousandths of an inch. That's not much, but over an inch or two, suddenly 10, 20, 30 thousandths of contraction from that red heat. If you think about a nut, as you turn a nut and it brings that material in, well, the rivet's kind of acting the same way. And that people will say, well, yeah, it gets tight, but many sort of engineering people in that I've ran into, well, they're like, well, how tight? And that's what I've made some samples and literally have even cut a joint like that in half, and it's still unbelievably robust. So that's something that seems to make the rivets just a great fastener, is that I'm putting a little candle wax to kind of help lubricate it here.
Do you
Let
prefer
that creep in behind them?
scented or unscented variety?
I've got my favorite sort of waxes come from garage sales, because what does a full tub of new wax cost? It's like $10, right? So if you can find at garage sales, the old Johnson's paste wax and things for like 50 cents, I'll get as many of that as I can. All right, well, we're pretty close there. I have several ways to, you can either use a carriage bolt with, it's got the square shoulder on it. And what I'd like to do, and I need to rethread it because I took it for a ride through the tumbler, is a little wing nut like that. Kind of make a little smithy sort of thing. Although I do have some of these with just a regular nut on the back. But basically taken from a little star shape like that and made. But that's secondary for me. It's like, does it work well enough to do the job? And it does. So that may conclude that portion. That I'd love to take people on a little tour. Or how are we doing on time, Kellen?
Oh, it's almost noon. I mean, we still got time. We still got folks in the audience. It's kind of up to you. We'd love a shop tour, and then I'm planning on running through your slideshow again at the end here. So.
Okay, well, let me give you guys a little tour. That's fine.
Sounds good. I've been kind of just so enthralled here. I kind of stopped running the auction. I'm just going to, in the chat, do a first, second call on where we're at. But let's go ahead and do a shop tour.
Got it. So, Bart, if you can follow me around. It's a tight space. I have 1,000 square feet, which isn't much. So the hot shop has almost always been a one-car garage. That's how I started. There's just enough room to pull it off, right? You got a vise, an anvil, or two. And my boatery, which I have several tools that have a Navy pedigree, and for some reason the Navy bought really good equipment. This was one of 3 that was sitting in a garage in North Seattle for 40 years. Came out of an auction in Bremerton in the 80s, and a former NWBA member named Tom Graham, who unfortunately passed away a few years ago, passed before he was able to kind of sell them off for himself. So he had his widow deal with the estate. But it's a 200-pound head. I started to rebuild it. And my old shopmate, who unfortunately passed, said, well, you did this, but you didn't do that. And I was like, well, what do you mean? He's like, well, these things, when we talk about mechanisms and that working together, like I may have done the gib, but the frame was still all not square. So I was kind of like, well, what does that mean? That means now it went from a 6-month to a 2-year rebuild, but every surface on this machine is being rebuilt. And I will tell those people who are watching that I can't say enough about the Beaudry power hammers. I think they're just remarkable. This one's rated for a 3B Nazel, which weighs over twice of what it does and also takes up twice the floor space. So the one thing that Beaudry really made me aware of was, other than the fact that these are the types of people that won the Civil War with the New England industrial output, was that there's a method to these, and that is everything goes back to James Nasmith, who was the inventor of the steam hammer. He also invented the shaper, which is used for things like cutting dovetails in these slotted grooves. And that is 1/2 inch, 1/4 inch, 1/8 inch, 1/16 of an inch per foot taper. 1/2 inch, 1/4 inch, 1/8 inch, 1/16 of an inch. And why? I mean, I was looking like all over the universe for what's the common, the unifying theory. And then when that dawned on me, a light went off, and I said, of course, that way the apprentice comes in, they hand him 4 little blocks of steel, said, there's your reference standards, go set the machine up. When we finally were able to characterize all this stuff, we found from there to there in the frame was off 1/2 a thousandths. I mean, the accuracy they were able to get 108 years ago, which my friend Kevin Willey from Wyoming, who's probably the best knowledgeable person on these hammers in the country, if not the world, dated this hammer as 1908. He actually makes this new casting out of 4340 right here, which is a real tour de force. This is chromoly. So great tool. I've got some tongs and things I need to finish up. This is some, again, Raku tongs sold to a gal in California. But let me show you really my pride and joy back here.
Before you walk,
they're kind of
real quick.
Sorry,
I seen when I visited your shop once. Is that running on a VFD?
It is. So yeah, this is Bart, can you show them down here? This is a Welding foot pedal. And it's run off of a 10 horsepower motor, which the crazy thing about it is when it's not running, you don't know it. There's no slack belt. You know, typically the old hammers had a big old flywheel running all the time. This is all done electronically with this control right here. Can use these to convert single phase power to 3-phase, but what they do allow you to do is run very intricate level of motor control. So those things were made for like bottling factories and things where assembly lines have to speed up and slow down. And believe it or not, you could program it like that, where you could sit back here with a button and say, okay, give me 3 strokes and that. But the foot control really gives a nice input. And part of the problem was I didn't have a treadle for this when I got it, and it was missing the brakes. So these things kind of solve themselves. Like I can go try to recreate pieces I don't have, or I had done this once before on my 50-pound Baudry, and I sold an air hammer the same day I got the little Baudry running, if that tells you anything, how I thought about its performance. But fantastic tool. It did. It was very tough because I didn't have a hammer for 2 years after I'd sold my Baudry. Here's a couple of presses, which one of these is an An Yang, the one on the right. An Yang, of course, is who makes all the Chinese air hammers. That's a 50-ton press. It was the first one I had. Great tool. This is the one I just made this last year. It's the first hydraulic cylinder I've ever made. It was really kind of my thesis about just trying to get better at my craft. And that means, I'm standing at the lathe and the mill, which I never knew how to run these things. When I'd bring home these machines and somebody'd say, well, what does that do? And I'd be, I don't know, so I'm grabbing levers and suddenly just start teaching myself the hard way. So this one's about a 40-ton. They're not big, but basically you can see the profile there. They're a very compact C-frame sort of shape. And these things get hung up from chain falls or whatnot. And it's kind of like scuba diving. When you're in the water, you're very maneuverable. And that is how these work. When you suspend them, you can bring them over I-beams and things and get to work. So this one right here is one I'm building based on a 140-year-old model of a company out of Brooklyn called the Allen Company. And they did rivets with big air cylinders. So this is a 3/4 scale model that should be able to drive 3/4 inch rivets, I'm thinking. And it does it all with the small diameter cylinder and levers. So it should operate very quickly. And when you hear me talk about doing rivets, you want to, get the work done fast, because that's when you get the best. It's an upsetting, a heading operation, right? So we know that the quicker you can get that material, Grant called it plastic flow, and it's true. You need to think about it almost like a liquid, how it needs to fill that cavity, and that speed is how you get there. And trying to form metals in a liquid state, almost, it takes an incredible amount of power in that. So that's what these tools help us do. These are a bunch of hand hammers I've got in various states of. I'm terrible. You have to spend days at the grinder on these darn things, and I just get sick of the bench work that I could do this all day long. However, I get really severe neck cramps in that, standing at a grinder for more than an hour. So as they sell on Etsy or my website, I'll stick a handle on them and go to town. So belt sander is a great tool to have in the shop. Polar Bear Forge sells this kit for a couple $100 online. Polar Bear, stick a motor on it. Great tool for really rapid removal. Take you guys outside. I got some, this is Bertha here. Bertha, we think, was built in the 20s or 30s. I had it chemically analyzed, and it's a very good pour of 1026 mild steel. So when this thing's operating, you'll see this flex about, I don't know, maybe 3/4 of an inch. And people are like, oh my God, it's not supposed to do that. Well, nobody's ever seen a rivet press really in action like this. So they flexed. And that's what C-frames do, unless you're talking cast iron or something. So I had Roseburg Hydraulics down in Oregon make the cylinder. From getting the drawing till when they told me to come get it was a week. I couldn't believe it. Other manufacturers told me 6 months to get a hydraulic cylinder made. So believe it or not, this is a portable tool. And it only weighs, actually, the Bodery weighs more than this. This is about 4 grand, and the Bodery is 4,400. So once you get over 2 ton with your tools, I can move the stuff by hand, you know. That just give me a pry bar, and I'll sit here for an hour and move stuff along. So well, come on over here. It's kind of in the fab shop portion. This thing was another basket case, went through a couple floods on a local river. And again, when I bring these things home, people are like, what did you do? You know, you brought home some turd. And that was a 1.5 year rebuild, which fortunately, I have a lot of friends that like to come over on weekends and kick tires and talk about fixing machinery and boat engines and all these things. So without their help, I never could have done these sort of rebuilds that we did. And this required some crazy mechanical gear puller that actually almost broke 13 3/8-inch bolts trying to pull. Well, the Swedes, don't tell me why they would shrink gears on and not use keys, but they did. And the gears spun on the shafts. So in order to get them off, we had to make a puller that basically scored the shafts, and it was this big crisis. But fantastic tool for metal forming and ring rolling. One of many hydraulic presses in the shop. Just picked this one up for $300. Drove up to Bellingham, but in order to make parts for that roller, you need a way to make a keyway, broach a keyway. And broaching is an operation where you scrape out the inside of a shape like that. So that shape right there is why I needed to get this machine going. This is a machine I haven't done too much yet with. It's a flanger. So with the rivets, I wanted to do more vessels and things. And I don't care if they're garbage cans or horse troughs or what, you know, I just like to get this sort of look out there. And this is kind of like a tin can opener, but it'll form an edge on sheets. So I can roll a ring, I can roll the barrel, but you still have to have a head for a vessel or a garbage can or whatever. And this is about a 100-year-old sheet metal tool I got for a pretty good price back east. And one of those sort of rainy day things. Got your Ellis. Machine shop's kind of crammed into a corner here. Navy tools that had, you know, that's the funny thing is these big tools that when they've served their time in industry, they get kind of thrown out. And, you know, yeah, they're not perfect and clean and all that, but for a guy like me, it seemed to fit the bill. So same thing, that they didn't run too well when they came in. Art, let's go back to this corner here. I really want to show everybody. This is kind of the honey hole here with some of these rivet shapes you saw, Kellen, that this is a master right here, how I'd form. Can you see that positive and negative here?
Yeah, and so when you're forming that, you're doing that hot? You're heating that bolster up and sinking that?
No, that's right. So yeah, this, you know, I'll either run that on the top if I'm, you know, driving a rivet head or something, or often I use these just for the fake rivets and just drop a slug in there. And so that's the kind of the beauty of the process is you can, like Grant said, do it on one side or the other, where depending on how, you know, you approach it. And but yeah, if you're going to do it on two sides, then certainly, you know, you need a front and a back, right? So that really is the nature of the process is for all that energy going into it from the front, you got to back it up somehow. And one thing I don't do too much of, I have the equipment for it, is the air hammers for all that. And Glenn, I think you bought an air hammer from me at Abana in Salt Lake, if I'm not mistaken, or maybe that was Jeffrey. Um, that's the classic look of, and most of these tools, you can still buy these from Michigan Pneumatic. For people that are looking for rivet stuff, you can buy these new, and those will fit the classic air hammers you can get on eBay or whatnot. Good ones, 300 to 500. You can spend more, and you can do a lot with those air hammers. But you have to be more creative in how do you back the work up. You either need somebody manually behind there with you, or you got to come up with some sort of a lever. Let me show you a tool that one of my students came up with in when I did the workshop at Center for Metal Arts in Pennsylvania last year, and I couldn't even have thought of this. This guy, Ted Bossaker from Texas, kind of an oil patch guy, came up, and we had a very tight. There was only this much room in between the beam where we had to get. So it's hard, to get something like that when there's not enough room. And I was like, oh, geez, I don't know what we're going to do, guys. So we upset a rivet head into a block like this. We literally made this on site. And with basically one revolution got us that 1/8 or 3/16 of an inch spread where it did the job. So classic case where it was like use the tools you got at hand. And really, this student of mine saved the day because I wasn't sure what we were going to do to try to solve that problem. And that,
Well,
I would say in riveting, that is one of the biggest problems is it's getting, like if you have an I-beam or something, how do you get inside of shapes that in riveting, it's all about the access, getting into tight spaces and that. So here's
seems like a
some
real
big ones.
genius idea.
I did this one on isn't that, I know it's crazy that just to know that we were able to kind of overcome the limitations. And that was a case where I wasn't even sure what our sculpture was going to be at the end of the class, and kind of throwing things together out of the blue there. But this is one from a couple years back that I mean, once you get into the realm of doing 1/2 and 3/4 inch rivets, then you're kind of stepping up into the big boy league. So what's to stop you then from going to 1.5 inches? And what made me decide to do rivets this big was looking at an old steel mill railroad car. Are you familiar with the hot metal cars? They call them a torpedo car. Basically, in a steel mill, they roll these train cars underneath the ladle. They pour 200 tons of molten metal into a car, and then it goes off on the tracks to another part of the mill or something. But many of these cars were riveted, and I kid you not, they used rivets like this. And I remember seeing these in the Railroad Museum, and I was like, oh my God, I have to go there because that took every bit of 100 ton. And it's the classic case is like, once you have that kind of power, you want more. So, is it going to be in your dining room table for an Etsy customer? Probably not. But, we want to be able to show that we can go to these places and do big things. So, I know Joe's commented on my Hausfeld posts. I can't say enough about these little benders like this. If you're getting new into the craft and you want to do more ornamental and architectural stuff, this is totally how, you come up with these kind of crazy bends in these sorts of things where by arranging the pins in different configurations, and I have different, I use like a 3/4 inch center pin there. I would say at least once a week, somebody asks me to make some kind of little bracket or something. And again, with a little bit of heat, you're suddenly the guy that can do it when people will come in and say, we've been everywhere, we've tried everything, nobody, well, we can. So that's good to know.
Well,
I mean, that's about it. So got a, you know, it's a small shop that not sure if there's anything else I can show you, or
well,
got question and answer from everybody.
Yeah, let's see. Stuart Shirley's asking, how did you bend those big chain links that were in the slideshow? You have that tool out?
That's great, Stuart, and I do, and I have. If you guys don't follow me on Instagram, I don't know. I mean, not everybody is on social media, but I built this one to bend 2-inch round, and it did. So you know, same sort of thing. I've got different sized pins in here. This is the bigger bender, so kind of like that rivet shear. I got a big old bar handle I stick in here, and it's about 6 feet long. This bolts down into the table, and that's where these platen tables really pay off, is that they're so heavy and rigid that, you know, you're going to be out here on that handle, and you know, and a more lightweight table is just going to flex in that. So yeah.
What a cool tool. You have a question, is that a plasma table you're actually underneath right now?
I do have a yeah, I try not to use it too much, but it's kind of for special projects.
To do it, or do you lower that thing down?
I have a like a chain fall I haul stuff up there with, Kellen, that my floor space is so limited here that I have to kind of be efficient. So this was kind of a trial. You know, I talk about getting the ends right. How hard is it? Well, that one was obviously a reject. So you know, and that's where the hot work comes in, is like, you're not going to bend that cold. And that was, speaking of the 1.5 times the diameter, that's a rule of thumb I learned from Portland Bolt in Portland about making U-bolts. If that radius is tighter than like 1.5 times the diameter, then they don't do them cold. So if you basically take a bar and you bend it back on itself, you really create a lot of stress in there. And if it's a large radius, you know, you can do them cold, but something this tight, you definitely have to heat it. You know, the problem is kind of keeping those ends square, and again, making sure everything's met up tight. So that one, I think that's 1 1/8. But those links, yeah, they were getting people made. Those things must have been costing them $1,000, because I was a fraction of that, and they were just thrilled I was able to make them for them. So this is a really cool technique that call that a hollow rivet. And I'll go grab the tool for that. I really like that technique. It's kind of like a grommet in you know, if you're making a canvas tarp or something, and you'll recognize these tools as when we all like made snaps on our blue jeans when we were kids or something, that basically you have to take and you know, that pipe's got to hit that cavity just right so it starts to roll over. I've seen a lot of guys forge pipe, and they'll just kind of flatten the sides of it, and it thins it out. So I did. So these were some of the first things I ever made on a lathe, where I will say that's what really kind of drove me towards buying a lathe was like I wanted to make all these rivet shapes, but then you're either going to pay a machine shop a fortune or you got to learn how to turn the knobs yourself. And that's where I didn't know what I was doing. I'd break tools, you know, I'd be in here late at night and scared that I was going to hurt myself or something. But that's basically made taking kind of a round edge tool and just digging it in there and making sure that shape just kind of fits. And I think that's some Schedule 80 pipe or something. But I've wanted to do more with that joint forever. And it's just a really comfortable kind of shape. And, you know, the fact that it's got, you know, that sculpture that everybody did for Welding, I know that they had some great big pipe rivets. I'd love to do that in like, you know, just some massive pipe, but it would take quite a bit of tooling. More just traditional half laps. I do like doing that technique, but yeah, no welds. You know, the thing's held together really tightly just with tenons and rivets and that. So really kind of simple operations, and that's kind of what I'm about is structure and holding things together. You know, how can you do it without having to resort to a weld or bolt? So in most things we're putting together, yeah, we could have used bolts for that, but then it's like everything else. And somebody asked me that on Instagram. They're like, "Oh, why don't you just weld it?" I said, "Well, because my welds don't get 100,000 views, you know, where the rivets, more people think that's attractive or something, or, you know, you got to admit hot metal looks great on camera. So it's just got the drama and all the mystique and all that. So not to say, you know, welds aren't great and all that, but the rivet thing is a little more traditional. So yeah, what else?
Well, you just got lots of comments here from like Patricia saying thank you for such an informative session, and Bujold saying this was a phenomenal demo visit. Thank you both, Steve and Bart. Stuart saying that, you know, awesome demo. Thank you so much. Yeah,
Thanks,
we're just
guys.
you're getting lots of kudos. I'm gonna share the slideshow one more time, so you guys can probably turn your camera off if you want, and if you want to peek over at the camera and just take a watch of the slideshow with us, that'd be great. But thank you so much.
We're gonna watch the slideshow one more time. All right, Kellen, sounds great. We'll check the slideshow with you.
Cool. Well, I'm just getting started. I would just point out that I sure do love your logo. It is such an iconic figure of that guy at the anvil. I always love seeing it.
No, thanks, Kellen. That you know, all I've got left are extra large T-shirts. Otherwise, I'd send you one.
Well, yeah, I'm not quite an extra large, but you know, maybe it's time for another run.
Right. Bye, Stuart. Yep.
So yeah,
God, I do like these.
Yeah, feel free just to like tell us anything you want to about these. Don't feel like you gotta tell us about every piece, but
sure. God, haven't done any animal heads in a while. My wife calls it Dungeons and Dragons. That she doesn't like all that sort of gothic stuff, you know.
Well,
but you gotta learn it, you know, when you're starting out.
Yeah, and dragons aren't for everybody.
Kind of my, yeah. Just a little towel bar there, you know. You bet, Joe. Take it easy. That was a bridge job in Georgia. That table sold to a guy and that was my first national client. That was kind of a big deal for me.
It's a real cool base. I sure do like all that joinery.
Yeah, it's a copy. Probably find the same thing at Pier 1, you know.
Well, I got to think this one's gonna hold up a little better than the Pier 1 version.
Yeah. Yeah, those were a fun thing. I just had a video on that on Instagram a little while ago. Those are like 1.5 by 3 inches thick.
Whoa, monsters.
Clamshells. Yeah, I got to make more of those tongs today. That's one beautiful thing. You can, you know, just old bolts lying around can make pairs of tongs out of them and turn a buck, you know.
I mean, we talked about this earlier. I just sure do like that channel that's been folded inside out.
Yeah.
Cool look.
It could use definitely more exploration, I know. And different size channels give you a different effect. Totally. Yeah, the Army Corps of Engineers. Yeah. What's that, Kellen?
Is that rivet press you got there? Is that Bertha that was outside? That's not. That's a different.
Oh, that's a one that's it's in the corner acting as a coat rack right now, which would be hard to see, but I made that one from scratch too. That's been a very good press, and it's only about a 15 or 20 ton. You know, that's the common myth, is that you need a 50 or 60 ton press to do everything. It's not necessarily true if you have a good high speed pump in that. It's more of that Gary Eagle inspired stuff.
Yeah,
I really like that. It's you know, it's a, what do they call it? Machine age, you know, kind of the Art Deco. It was really like an angular cubist. You know, the craftsmen of the period were kind of wrestling with, geez, there's all this automation happening. How do we adapt? You know, and I think they were able to do that pretty successfully.
Oh, sorry, I'm sensitive mouse.
Yeah.
More Dungeons and Dragons.
Yeah, more Dungeons and Dragons. Yep. Yeah, I haven't done any heads in a while. I'd like to. They were kind of popular.
Yeah, I've seen some of these totem heads you've made before, and I sure do like the style. They look really cool.
Yeah, I would love to do more sculpture. You know, it's maybe when you got time to retire, you know, and just make pure art, that it'll come easier. But you try to scratch the itch when you can, you know. And yeah, those kind of flowers are definitely fun. The burger buns.
The burger buns.
Yep.
Well, Steve, I sure do appreciate your breadth of work. I mean, you do so many different things and you do them all so well.
Well, thanks, Kellen. It's an honor to be with the club, and you know, I think that's really what makes the Northwest Club really unique, is there's just a lot of different talent, you know, and guys hiding out in the woods you never heard of, or people that are very talented that inhabit this area. And I think that it's second to none, you know. And I think the best of our club can hold their own with just about anybody. So if I can be a small part of that, then I don't, you know, I've always kind of been a contrarian, where if everybody was out making one thing, I tried to go the other way. But you know, try to dabble well enough to get proficient in something and then move on, and just try to be You bet, Jeff. We'll see you. And yeah, tools, hard to beat. Good tools, you know. I do like walking into other people's shops and you see them with a pair of tongs you made or something, and that's their favorite tool. Yeah, that was Bertha in the rebuild phase, because everybody likes bringing home a 4,000-pound chunk of steel, you know.
Yeah, I mean, as long as you got something to move it with, huh?
Yeah. You know.
Well,
That was
Steve,
Bridge Project. Yeah.
what a great demo
Bet,
all
Dan.
this
Thanks.
has been. Thank you
Yeah.
for sharing this.
That was a 035 donk. Yep.
Okay.
Yeah, that was a Bridge Project. Staircase. Yep.
Back to one of my
Bet,
favorite.
Kellen, and I love that photo too, man. That yeah, high steel. In another lifetime, you know, I built skyscrapers in New York 100 years ago, and there's just something very liberating about it. Yeah. I'm sorry?
Oh, no, I just clicked the mouse wrong. I got a sensitive mouse here. It likes to fly through these pictures sometimes.
Yeah.
Well, Steve, I'm looking forward to the next time we get to come visit you. Maybe we can fire up one of those big tools you got and see something heavy done. And
absolutely.
I'm really looking forward to the day that we can get back together for a conference and pull together the demo you were hoping to do. Because I think seeing this in person.
Yeah. You bet, Charlie. Take care. All right, Doc. Well, thanks, everybody, for coming out.
Yeah, thank you, everyone. It's those massive chain links.
Yeah. Yeah.
Well,
simple stuff, right?
That was the end of it. Thank you so much, everyone, for coming. I'm gonna call this meeting over. Steve, Bart, both you guys did great today. Thank you so much for letting us into your world, and I look forward to the next time we get to visit you.
Absolutely, Kellen. Thank you so much.
Well, cheers, everyone. Hope you have a great rest of your weekend.
All right, everybody. Bye-bye.